fast forward a few, and we have our Butterizer with our itty bitty 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 DFN8 switcher, which is, as you can see, the LTC 3539. And here's a schematic, by the way, for the Butterizer. It's extremely simple. Not to devalue the thought that went into putting this together and laying out the board, because there was definitely some. But it's a simple, it's your basic boost topology. Although you might notice that there's at least one component that's typically in these guys missing. You've got the standard input here, output here, filter caps on the output to get rid of the switching noise. Of course, there's no filtering on the input, which means that we'll be barfing switching noise back into the source, but that's another problem. We have our feedback here on Vout, so we can tell, the switcher can tell what's going on. And we have our inductor here, our 4.7 mic inductor. Now, the two other parts here that are missing from here, but not necessarily surprising, is the FET switch itself. That's sometimes integrated inside the actual IC, and in this case it is. But the other thing that's missing is the diode. So normally what happens, you switch this, the switch will be routed to, or you'll be switching to ground. So basically you'll short the coil to ground, which will charge it, and then you'll bang shut it off, which will leave the current in here no place to go, which will then be shot forward through the diode into the caps, and that will boost your voltage up on this side. And in this case, we don't have that. The diode's actually part of the switcher itself, so we'll take a look at that. But right now, what I want to do is, after having soldered this little guy in, I didn't bother checking if I got any short bridges, so we'll give it a quick test right now. So, of course, the nice thing about before you put any components is pin 4 and 1 will normally be shorted, but they won't be right now. And they won't be shorted to ground. Pin 7 should be shorted to ground, which should be the only one that's shorted to, oh sorry, the 3, 9, and 2. Or 9. Oh, that must be the thermal pad. So 7, 3, 9, and 2 are okay to be shorted to ground. 5 will not be. 4 will not be. 1 will not be. 8 will not be, and neither will 6. So let's go take a look. In this case, it's hard to probe the actual connection, so what we'll do is we'll probe the pads of the actual components they're attached to. So 5, let's start simple here. We'll have the input here should be attached to Vin. This side of the inductor is attached to the cap, so that's this guy right here. So technically, this should be shorted to ground. Actually, we'll switch to the beeper mode. So the ground is common here, so we'll do this. Good. So the other side of this is pin 4. So we'll just make sure that this is not shorted. Well, there's a diode, but whatever, that's fine. The other side of the inductor, again here, should not be shorted. Nope, it's a diode, so we're good. Pin 8 should not be shorted. Pin 8 is going to these two resistors here, which are, I can't see anything because the thing's so darn small. Teeny weeny. I'll C2. C2 is right here. So the output. Now we have a diode drop, and that's fine. There's nothing wrong with that. And what else do we have here? So these two, so pin 1 and 4 are fine, pin 5 is fine. Pin 5 and 4 should be shorted together. So if we look at our pin output here, that's shorted. It's hard to get at pin 5. We'll try. Those are good. Excellent. So I think we are, and feedback should be on the other side.
7 is grounded. Pin 2 should also be grounded. Yeah, pin 3 should also be grounded. Life is great.
Now I got a whack of components here. Let's see what's the easiest. These are the tiniest reference markers I've ever seen. This is R2. That's got to be R1. And we'll just do a quick check to make sure that that is indeed R1. Okay, that's one. Okay, good. Alright, so 4 meg will go into R2, so there. I'm gonna put R1 in first though, because that'll be easier for me to get at. And then I'll come and do R2 in a second, right after that. There we go. Oops. Way to go, genius. It didn't take me too long to solder this sucker, and the biggest problem was actually the pads in the end, the regular pads, not the thermal pad. Thermal pad wasn't too big a deal. Oh, haha. That's a big part. No, that'll be fine. And this was 1 meg, and that's right, so we're going to do this side. But we're going to clean that up, oops, first with a little bit of solder wick. Still has the grossness from my my work on it at lunch. Gotta say, the flux remover that I used at work was really good. Worked out really, really well.
Fairly happy with that stuff. Might have to get some for the lab here. Okay, there we go. Oop, hello. Oh well. Okay, so the way I typically do this, can you see any of this stuff? Yeah.
Yoo-hoo! Okay, so now I need the 1 meg. I'll just roll that back in. As you can tell, I don't do assembly line work. I'm way too slow to be able to do that stuff. Let's put the 4 meg in. After all this, I'm going to have to do some tests, I suppose.
Sort of show off what this sucker can do. Now I gotta say, anonymous guy really did an okay job with these pads for the passives. This has been a fairly easy job to solder these guys.
This is damn
these damn ground planes. That was a pain in the butt.
oh, that's fine. Alright, next. At some point I figure you all will get very bored of me building stuff and then stop watching my channel. In which case I'll probably be winning. But until then,
thanks for coming along for the ride.
So next comes,
I have two 22 farad, 22 mic caps.
I could probably do the inductor now, technically. Give it some big beefiness. Now, these inductors weren't cheap. They were like a couple of bucks. It was like $2 to $4 each, I think. $3 to $4 each. It's funny Canadian dollars, by the way, not American greenbacks. But yeah, kind of expensive. And of course, the switch chip was like $8, so that's crazy.
We'll just come in here, just tin that pad. I don't think it matters which way the inductor goes, as silly as a question that might be. I do know that transformers can be wound in such a way that they have sort of a preferred winding, a phase if you will. But in this case, it don't matter a lick, I don't believe. So just get in there and get her done. In this case, I'll probably put a little bit of flux underneath there. I'm thinking, well, that was okay. Of course, on second thought, maybe soldering on paper is not such a hot idea, huh? Or maybe it's too hot an idea. Okay, there we go. It's not too bad. Okay. So, next we'll do the... Where does that 47 puff go? And more importantly, why did I order 47 puff? It clearly says 33 puff there. Well, I can always change it. So it's, I'm pretty sure actually this is probably on the bottom now that I think about it. So maybe anonymous dude changed that. So what I'll do is I'll put this one in. I mean, it's no big deal. It's just solder and components. I can always take it off and replace it. I do actually have some 33 puff caps, which I think are probably a bit smaller than this. These are probably, oh, these are 0603, yeah. So it's probably the same size. So worst case, I'll just go ahead and replace it if need be. But I don't think. I think the this may have been recalculated, and perhaps the schematic not necessarily updated. Which, you know, happens. Look like there. Yeah, that's a nice big fillet. Alright, so this was so that's done. So we now just have the 222 mic caps, and we are done. These guys weren't cheap either, if I remember correctly. Well, as far as SMD caps go, they weren't cheap. And it's not like they were like $2 or $3, but each. But I think they're like 30 or 40 cents each or something like that, which is, you know, you make $1 million, if you need $1 million of these, that's some big dollars. So which one of these is connected to ground? Oh, I don't know if I like that. I have to look at the routing, but Mr. Experienced board layout guy here, not. So it's hard to tell because the solder mask is a little wonky. You might be able to see if I shine there, but basically the output is coming from here, well, here, and going through to here. Now it's being picked off here for the feedback, and here's one of that. Here's that the 33 or 47 puff cap, and the other two, these are the two big caps, but you can see they're sort of like attached like this, I think. Yeah, I think they're attached like this. And that's a tough one because technically speaking, this is the shortest pathway here. So you technically want to pick off on there, and you know, indeed, just moving both of these this way may have been a better idea. Not sure. Or maybe putting one of these over here, picking the, well, the feedback probably is right here. Yeah, so the feedback probably had to go there. But this cap could have been over there, and this one could have been over here. Or something. So there is the Butterizer. So there is the Butterizer.